This is a gate problem that came in the year 2013 and is on diodes. The problem is stated as a voltage 1000 sine omega t volts is applied across YZ. Assuming ideal diodes, the voltage measured across Wx in volts is option A sine omega t, option B sine omega t plus mod of sine omega t whole divided by 2, sine omega t multiplied by mod of sine omega t whole divided by 2, and option D is 0 for all t. And this is the circuit. So this is the YZ terminal across which the input voltage of 1000 sine omega t has been applied, and this is the 1 kilo ohm load resistance across which we want to measure the output voltage. So remember from our previous videos that for an ideal diode, if the diode is in conducting mode or it is in on state, then we should substitute it with a short circuit, and if it is in non-conduction mode, basically in reverse bias state, and this acts as an open switch or as an off switch. So in that case, you replace the diode with an open circuit. So if we break the input signal into two halves, the positive half cycle and the negative half cycle, then we can proceed with the circuit evaluation like so. So for positive half cycle, the direction of current flow will be in this direction from bottom to top, and we find that these diodes are going to oppose, both these diodes will oppose the flow of current because we are trying to push current through the diode from cathode to anode, and the diode will block a current flow if we try to do it like so, and therefore there is no circuit flow, no current flow throughout this circuit, and hence the drop across this load resistance will be 0 volts because the current is 0, and then current multiplied by resistance is the voltage drop, and this is equal to 0 volts. So when we are in the positive half cycle of the input waveform, then the output voltage is 0 volt. This is simply because these top diodes are acting in reverse bias mode. Okay, next is the negative half cycle. So in the negative half cycle, the voltage source will try to push the current in this direction, and this is in conjunction with the direction of the diodes. So the diodes will allow the flow of current through itself because now the current will flow from anode to cathode for this diode as well as this one, and then anode to cathode for this right hand side, both the diodes. However, if we look at the voltage drop between these two nodes, we find that this is a direct short circuit, and therefore no current should flow through this load resistance. Basically, this is a symmetric circuit, and so the current will simply loop through within these two loops, and therefore in this case also the output voltage will be equal to 0 volt. So this time around, even if all the four diodes are in conduction mode, however, no current is going to flow through the load resistance, and therefore the output voltage is 0 volt. So in terms of waveform, again from t by 2 to t, we can draw this to be a 0 volt line, and in terms of our option, answer D, which is 0 volt for all t, is the correct choice.